can check if the image is in your virtual machine using the command docker image ls to list all the images that are in the VM. So you can see that the first one is the one for REPET, and you can see that there is also the one for Clément later. And then you can start to follow the tuto. So there is two possibilities to build your container from this image. You can build the container with this simple command here to create a container. Or what I will recommend is to bind a directory on your container to make it easier to manage your file in the container outside the container. As you have this directory, you can put your file in the directory and you will have access directly from your local. I hope that I'm clear. But Clément will talk about that later also. So we will try to bind a directory. So first of all, you have to create your directory. Work. Dear. Oh, there is nothing. Okay, so we can use this directory with this command. You just have to change the XX by the name of your session. So for me, it's instructor. And here we are. So the, sorry? So then you can check if your container is created. So we have our container, and then the status is up, so you can go inside. So I'm inside. And is it okay for you? And inside the container, there are different directories. So I go back to the tutorial. As it's right here, there is to make it easier for you, we create a directory with the config files that are mostly filled. And there is a directory to that prepare every data needed to launch REPET. That is which name is example ready to test, and another one with the same data but with the result already get. So if I go in the directory to launch, what we recommend for your work with REPET is to create a directory dedicated to one of the pipelines, so one for TEdenovo and one for TEannot. So if we want to launch TEdenovo, we go inside, and here we are. So TEdenovo need your FASTA, the FASTA of your genome. You need the config file of TEdenovo that you can find in the directory of the config files that I showed you just before. And as TEdenovo include PASTEC, PASTEC needs some banks that are needed to help for the classification. So here we have the last of freely available version of REPBase. And we also have a profile and rRNA bank. But in fact, you can use which bank you want. You could use TEhub or other bank. And what we recommend before starting with REPET is to in fact, some problems that people can have is when the FASTA is not formatted for REPET. For example, there are some forbidden characters in the header, or if the sequence is not in a column of 60 bases, that do not work. So there is a pre-process step to format your genome for REPET. So this is what we have here. So if you copy paste the command, so here we call the pre-process. Step one is to just format your input. The I is for your input, and that's it. You can launch it. Normally, it's not so long, and here we just have the DML is the chromosome 4 of Drosophila melanogaster. And preprocess will build a directory which name is name of your input underscore check FASTA. So if you go in that directory, you have these results, and the most interesting file you need is the name of your input file, point formatted. So now we are able to launch REPET with the input file that is formatted for REPET. Yes. When I present my poster 2 days ago, many people ask me how do they manage with large genome, and preprocess allow the possibility to do a subset of your genome. So I present the paper which describe the benchmark that have been done to test this approach. And if you complete your preprocess command with this option, you will have your input file formatted and subset to get only 300 megabases. But here we don't do that because the input file is lower than 300 megabases. So we can now launch TEdenovo. So we have to rename the input file. That's why we do MV. And then we can build a symbolic link on the formatted file. Now we are ready to launch TEdenovo. So there is a command to launch all the pipeline using the launcher. and it's okay for me. I hope for you it's the same. So TEdenovo is running currently, and if you want to see which results you will obtain, because we haven't got enough time to wait for that, you can go in the directory, which name is example ready to test with results. So it's a kind of a mirror with the results, so you can see what you will obtain. In the tutorial, we give you the information of which file are mostly interesting the user. The more interesting output of TEdenovo is the FASTA file with the consensus. But also the classification of the consensus. So the two main files of TEdenovo are this one, and you can see them in the directory for which you have the results. And there is also some statistics here. So these are the three main files used. So then we can try to launch the other pipeline of REPET. So you have to go in TEannot directory. In TEannot directory, there is the config file, and you need to get your reference library and your genome. So you have to create some symbolic link to get this file, and you have the command ready here. So here is the link to text from TEdenovo the consensus file that will be your reference library. But yes, that do not work because the file do not already exist. But other way we could take it from the directory with the result. But how do we do it? I will put the genome, and we will see if the results are already. Okay, so to be able to launch TEannot, I have to remove the symbolic link that do not work and to replace it by the same file, but in the other directory. But time is going so fast, so I don't know if we will have. But anyway, if we don't have enough time to finish the demo, all you have to know is each command needed to launch TEdenovo and TEannot are in the tutorial. If you find some bad commands or commands that remain unclear for you, we are open for feedback and suggestion, or if there is a need for more explanation or additional commands, we can improve it. It's just a first version. And what I wanted to say. Yes. The other thing that people ask for me when I was in front of the poster is how to avoid to get too much manual curation, and still from the same paper with reference here, the idea of to reduce the manual curation of the reference library is to run 2 times the TEannot. The first time is to get the information of which consensuses annotate a full-length copy. And with that information, you can select a subset of consensus on your reference library using only the consensus that annotate at least a full-length copy. So in general, that will reduce your library of around 30%. So it's a way to get a lower number of consensuses with keeping the same genome coverage. So for that, I let you also the command here to be able to get the information of which consensuses annotate full-length copy. And then you just have to relaunch a second run of TEannot. So if we, with the 5 minutes I get, we will try to launch the TEannot. So maybe now I can, no. So now TEdenovo is finished. That's why my symbolic link is working. And that's why I should launch TEannot. So you just have to copy paste this command. And it's running. Is it okay for you? No? Question? So, yes, I haven't got time to show more, but yes, with all these few commands, you are supposed to be able to launch TEdenovo and TEannot. As I explained you at the beginning, you are not obliged to build your consensus library with TEdenovo. If you already have a library, you can just use your library with your genome and launch TEannot. Or in the other hand, you can build your library with TEdenovo and then, for example, you use other tool like REPET masker. Or use only PASTEC if you have a library for which you need a classification. And what you have to keep in mind for the usage of PASTEC is the classification will depend of the quality of the bank that you are using. So it's better for you to select a bank that have a reference close to your species. And that's it. If there is few questions, maybe we have a bit of time.
Then what size is considered as a fat genome for REPET?
In fact, there is no, this question really depends on the computational resources you have. In fact, fat genome could be launched without doing a subset. But if you haven't got high computational resources, that's going to be hard. And for example, 1 gigabases could be launched directly without doing a subset if you have high computational resources. But in the publication, the case we use is the width. The width is 16 gigabases, so it's quite hard to manage with that kind of genome. So we have to find ways, and it was a solution.
Big round of applause for Johann. Thank you so much.